All right, let me solve out the review packet with you guys now. Okay, so solve by graphing. My first attempt is always try the slope-intercept form, but don't forget to number your number line first. So 2, 4, 2, 4, 2, negative, negative 4, negative 2, negative 4. Okay, so I'm going to try to color coordinate this. With number 1, my m equals negative 3 over 1, and my b is negative 8. Okay, and number 2, second equation, my m is 2 over 1, and b is negative 3. Okay, so I'm looking at this. Number 2 is okay, but number 1, the first equation, I don't have enough space to do negative 8. Okay, so I'm going to have to use a different method for that. So let me go ahead and do the easy one here first. I'm going to try to graph that. First, to start at negative 3, the y-intercept. So here is negative 3, and then I go up 2, and then right 1. Up 2, right 1. Up 2, right 1. So when I get several points, I can even do down 2, left 1. Okay, so there's that. So first equation, I can't do it the way it is. I'm going to have to make a t-chart and try to come up with a number that works for me. xy. Okay, so I know y is negative 3x minus 8. So I want to try to get a number that's going to give me a relatively reasonable y value. If I put in 0, I know it's going to be negative 8, which I just concluded I don't have enough space for that. And if I put in like a positive, I don't know, positive 2, that's going to be negative 6 minus 8, which gets me bigger negative numbers. So I'm thinking I need to plug in a negative number for the x. Okay, so be strategic in what you figure out for your x. Let me try, I don't know, negative 2. Then it's negative 3 times negative 2 minus 8. That gives me what? Positive 6 minus 8. Okay, so this is doable. That's negative 2. So my coordinate is a negative 2 and negative 2. So I'm going to plot that right now. Negative 2, negative 2. Okay, that looks good. All right, I'm going to keep going with this pattern and maybe do negative 4 next. Then I have negative 3 times negative 4 minus 8. That's 12. Take away 8, which gives me 4. Okay, so when x is negative 4, y is positive 4. Okay, negative 4 and positive 4. Okay, so this is not bad. I want to point down here because I'm looking at this. My blue graph is going to look like this. I think I can even like try to extend my line as long as I do it carefully. I might be able to find the point where they cross each other. And ta-da! I think I have it. Okay, I just want to double check. Okay, my slope is supposed to be negative 3 over 1. So that's from here to here. I go down 3 and right 1. So I know I have the correct point. Okay, so that's where they cross each other. So my solution is at negative 1 and negative 5. My x is negative 1 and y is negative 5. Okay, and I can even do the happy check at this point. I'm going to go back here to the happy check on top of the problem. What is it? Y negative 5 equals negative 3 times negative 1 minus 8. That gives me positive 3 minus 8. It is negative 5. So happy check. All right, so there's the answer for that. Let me highlight my answer. Moving on, next one. Okay, so this is, I don't want to rewrite everything in the slope-intercept form, okay? Because they both are like not in the slope, it's in the standard form. So I'm going to try to recall finding the xy intercepts. Then number 1, number 2. So for my number 1, let me show work here. For my x-intercept, I have my y equals 0, okay? So x minus 2 times 0 equals 6. So it comes out to x equals 6. That's my x-intercept, okay? And for my y-intercept, I let my x equals 0. So it's going to be 0 minus 2y equals 6. Divide both sides by negative 2, y comes out to negative 3. Okay, so my x-intercept is at 6, y-intercept is at negative 3. Let me number my number line, 2, 4, 2, 4. negative 2, negative 4, negative 2, negative 4. Again, my x-intercept is at positive 6 on my x-axis, and my y-intercept is at negative 3 on my y-axis. I connect the two dots, ta-da, to infinity and beyond. There we go. There's my first equation, okay? And I'm going to do the same thing with my second equation. Find x, y-intercepts. Okay, so x-intercept, I make my y be 0, so it's going to be 2x minus 4 times 0 equals negative 8. So that's a 0. Now I divide both sides by 2 to eliminate the times 2. So x comes out to negative 4. That's my x-intercept. My y-intercept, x is 0 this time. So 2 times 0 minus 4y equals negative 8. So that turns into 0. So I have negative 4y equals negative 8. So divide both sides by negative 4. Y is positive 2. Okay? All right, so I can graph this now. X is at negative 4, and y is at positive 2. Ooh. Did I do something wrong? Let's see. Or are they parallel lines? I think they might be parallel lines. Let me count the slope for this one. Figure out the slope. Slope is 1, 2, down 2, 1, 2, 3, 4. That's negative 2 over 4, so that slope comes out to negative 1 over 2. The pink one, from there to there, 1, 2, 3, negative, oopsie daisy. Let me do this again. 1, 2, 3, negative 3, 2, 1, 2, 3, 4, 5, 6, positive 6. So it does simplify to negative 1/2. So this is no solution because the lines are parallel. No solution. Okay, so that's the answer for that. Oops, daisy, I meant to grab the highlighter. All right, next one. Okay, so, I think first equation I'm gonna, oopsie daisy, use xy intercept. Where is my pen? Xy intercept, and then second equation I think I'm gonna use the slope intercept form. So anyways, let me do number 1, x-intercept, y equals 0. That's negative 6x plus 2 times 0 equals negative 2. That's negative 6x equals negative 2 divided by negative 6. X comes out to 1/3. X-intercept is at 1/3, it looks like. Okay, that's okay. Not the prettiest number, but that's okay. And then my y-intercept, I make my x be 0. I don't know, I started doing blue all of a sudden. Let me just change it back to pink. Okay, so negative 6 times 0 plus 2y equals negative 2. That erases, or that goes away. 2y equals negative 2 divided by 2. So y equals negative 1. Okay. All right, so I'm going to keep that there for now because I'm pondering how I'm going to graph that. X equals, x-intercept is a negative, it's at 1/3. Okay, let me go to the second equation, this one now. I'm going to rewrite this in the slope-intercept form, meaning I'm going to add 3x on both sides. So it's going to be y equals 3x minus 1. Okay? Okay, so that one should be pretty easy to graph. It's just that this x-intercept is at 1/3. So I don't know how I feel about that. Let's see. X 1/3. I'm just trying to see if I want to make it go up by 3s. I really don't like this problem too much. Let me just double check and make sure it is 1/3. If I put in 1/3 here, that's negative 2 plus 0. Yep, it is 1/3. Okay. Let me just graph it the way it is and see what happens, okay? I'm just going to go up by 2. You know what? I really don't want to go up by 2. Since it's 1/3 and I'm graphing, solving by graphing, I want it to be more exact. So I'm going to go up by 1/3 and make this to be 1. And make this to be 2. Hopefully, I'm not going to run out of space. Negative 1 and then negative 2. And as far as my slope, y goes, I'm going to just go up by 1, 2, 3, 4, 5. And this is totally okay. Okay? -1, -2, -3, -4, -5, and so on and so forth. So let me do the easier one first. So my y-intercept is a -1. And then I go up 3, 1, 2, 3, and then rise 3, and then run 1. But remember, 1 is this whole 3 tick marks, okay? And that's 1. So rise 3, run 1. That's it. Rise 3 and run 1. But again, my interval for x is different. Okay, it goes up by 1/3. So that looks like my graph right there for the second equation. Okay. And for my first equation, my x-intercept is a 1/3. So that's 1/3 right there. And then my y-intercept is a -1. Oh, wait a minute. Are these same equations? Oh, what the heck, Eddie? Are you kidding me? They are indeed same equations. Oh my goodness. And it makes sense because when you look at this, if you multiply this whole equation by 2, that gives me -6x, 2y, and then -2. It does happen to be same equation as the first one. That is very funny. So this is infinitely many solutions. Infinitely many solutions. Okay, that was kind of interesting. All right, next one. We can do xy intercepts, but I just like my slope intercept forms. I'm gonna rewrite this in slope intercept form. Let me color coordinate this like the way I've been doing. So I'm gonna use pink. I want my y to be alone, so plus x on both sides. That's 2y equals x minus 4. Sorry that I'm squishing in work right now. I'm going to write this over here. That comes out 2. Now y, it cancels out y. And then equals 1/2 x minus 2 is my new equation. Okay? And then for my second equation, this should be pretty easy. Subtract 2x on both sides. So I get y equals -2x plus 3. Okay? All right, so now we've got 2, 4, 2, 4, -2, -4, -2, and -4. Okay, pink equation. First one, I start at -2 for this y-intercept. I rise 1, and then I run 2. Rise 1, run 2. Rise 1, run 2. And there is my line right there. And my blue equation, I start at 3, okay, right there. And then I go down 2 and then run 1. So down 2, run 1. Down 2, run 1 up. I found their meeting point right there. There you go. And the solution is at, what is that, +2 for x and -1 for y. 2 and -1. I'm going to quickly do happy check right now. So y is -1 minus 2. Okay, that gives me plus negative. That's -2 plus -2, which is -4. So happy check. Okay. All right, it says, oh, let me highlight my answers. Right there, and this was infinitely many solutions. Okay, next one. It says determine whether the given order pair is a solution of the system of equations. Write yes or no. Okay, you can't just write yes or no, you got to show work. Okay, so I'm going to substitute in 2 for x and 3 for y. Equation number 1. -7 times 2 minus 3 times 3 equals 23. -14 minus 9 equals -23. At the opposite, that does come out -23 equals -23. Happy check. Let me do the second one now. I've got -3 times x, which is 2, plus 2 times y, which is 3, equals -1. It's -6 plus +6 equals -1, which is not true. This should equal 0. So this is no, not solution. I should say not happy check. All right, next one. I just want to make sure I got everything. Yep. All right, so another yes or no. Again, this is x, this is y. First equation, 4 times x, which is 6, plus 3 times y, which is 3, equals 33. That's 24 plus 9 equals 33, and that is indeed true, so yes, happy check. My second equation, x minus y, oops, let me plug in numbers. X is 6, so 6 minus y is 3 equals 3. Yep, that's an easy one, happy check. So this is yes, it is a solution. Okay, so let me highlight my answers, yes and no. All right, second page. Use substitution method to solve. So here we go. This is already isolated. So I'm going to substitute that in the place of y right there. Okay, so bring that equation down. So x plus 2 times y, and again, the whole quantity is same thing as y. So I'm going to substitute in the place of y. 7 minus 3x equals 4. Let me draw the wall. So x plus 14 minus 6x equals 4. X plus negative 6x is negative 5x plus 14 equals 4. Subtract 14 on both sides. So I get negative 5x equals negative 10. Divided by negative 5 on both sides. So x comes out to positive 2. So I have one answer. Now I have to look for y, use that equation to solve for y. So y equals 7 minus 3x, and x is 2, equals 7 minus 6, which equals 1. So my solution is 2 and 1. Okay. And then again, quick happy check. Let me use red. X is 2 plus 2 times 1, that does equal 4. Happy check, yay. All right, next one. Let's see, we have, it's supposed to be using substitution method, so I am going to maybe isolate the x on the top. Okay, so x equals 11 minus y. I'm just subtracting y on both sides like that. Okay, so it's 11 minus y. So I'm going to take 11 minus y now and put it in the place of x on the second equation. Okay, so I'm going to again bring the 11 minus y and put it right there. So it's going to be 3 times 11 minus y minus 4y equals negative 9. Oopsie daisy. Negative 9. Distribute it, so it's going to be 33 minus 3y minus 4y equals negative 9. We subtract these, or rather add those because they're same signs. It's 33 minus 7y equals negative 9. Subtract 33 on both sides. I get negative 7y equals negative 42. Divided by negative 7 on both sides, I get y equals positive 6. Okay, now I'm going to take that and plug it into this equation so I can find x. X equals 11 minus y, and y is 6. So it comes out to 5. X equals 5. So I have 5 and 6 as my solution. And of course, you should always do the happy check. So let me do the happy check. X is 5 and y is 6, and you add them up, they do equal 11. Happy check, yay. Right, next one. Okay, I think this one will be the easiest if I plug in 5x in the place of y right there. Nice and simple. So I'm going to rewrite that as 5x equals 4x minus 4. Subtract 4x on both sides. So I get x equals negative 4. Okay, so I have x now. I'm going to use this equation to find my y. Y equals 5 times x, and x is negative 4, so y equals negative 20. So my solution is negative 4 and negative 20. And don't forget to do your happy check. All right, so let's see. negative 20 equals 4 times negative 4 minus 4. That gives me negative 16 minus 4 is negative 20. Happy check. All right, next one. So again, they want me to use, substitution method. So I think I'm gonna maybe isolate this variable y, okay, by adding 2x on both sides. So this one turns into y equals 2x plus 5, okay? So I'm going to take 2x plus 5 and plug it in into the place of y right there, okay? So bring back down that equation. X plus 2x plus 5 equals negative 4. X plus 2x is 3x plus 5 equals negative 4. Subtract 5 on both sides. So 3x equals negative 9. Divided by 3 on both sides. X comes out to negative 3. All right, so I'm going to take the negative 3 now and plug it into this equation to find my y. So y equals 2 times negative 3 plus 5. Y equals negative 6 plus 5, so y equals negative 1. So my solution is negative 3 and negative 1. And it's time for happy check. So I go x is negative 3, y is negative 1, and add them together. They do equal negative 4. Yay, happy check. All right, number 11. Write a system of equations to solve. Okay, so the sum of two numbers is 58, difference is 22. Find the numbers. This one's easy enough. Okay, so x be the first number. Y be the second number. First equation should come from this one. The sum of two numbers is 58. Okay, so x plus y equals 58. Second equation, the difference is 22. Okay, so second one, x minus y equals 22. Okay, and I believe this one you still have to use substitution method. I know some of you guys would like to use elimination, and elimination sounds like a good idea, but right now we are going to use substitution. Okay, so you know what? It's silly to use substitution. I'm going to just use elimination, and that's totally okay. You know how to use substitution, so that's okay. But elimination is so easy. I'm just itching to use it because this cancels out. Look at that. So much easier. So 2x equals 70, 80. Divided by 2 on both sides, x equals 40. Once you find out x equals 40, you take one of the equations and find y. So 40 plus y equals 58. Subtract 40 on both sides. So y equals, what is that, 18? Positive 18. Okay, so your answers are 40 and 18. Numbers are 40 and 18. Okay. And the sum, when you add them up, it equals 58. When you subtract them, it does equal 22. So check. Okay. Let me put a cloud around it. Okay. Next one. Use elimination method. Okay. This one is ready to go because I can cancel these guys. They are opposites. So I love it. It's already set up prettily. Add them up. So these together give me negative 14y. So negative 14y equals 14. Oh, this is super easy. Divided by negative 14 on both sides. So y comes out to negative 1. Okay. All right. So now I'm going to take, I don't know, this equation, because the first one has too many y's, and solve for x. 5x plus y is negative 1 equals 14. Okay, now we add 1 on both sides. 5x equals 15 divided by 5. X equals 3. Okay, so here are our solutions. 3 for x, negative 1 for y. Let me quickly again do the happy check and check my answers. So negative 5 times 3 is negative 15. Minus 15 times y is negative 1. That's 15 plus 15, or negative 15, it turns into plus 15. That does equal 0, so happy check. Next one. Okay, again, using elimination, I can't eliminate them the way they are set up. So I'm gonna, I don't know, try to eliminate the y maybe by multiplying this whole thing by negative 3. Okay, because this is 3 and I need it to be negative 3 to eliminate it. So I'm gonna multiply everything by negative 3. I'm gonna rewrite the equation down here below. That's negative 9x minus 3y equals negative 45. I don't know why I started using the red, because red, I've been using it to do the happy check. Let me change it back to pink. Okay. What happened there? Okay, so I'm gonna now, so we're looking at these, we're looking at, where's my pen? These two equations now. Okay, we're gonna solve those two equations. So forget the first one now, okay? And then, if you look at this, I can cancel that out. Okay, and then I get negative 3x equals negative 15 divided by negative 3 on both sides. X equals positive 5. Okay, so I have my answer right there for x. Now let's solve for y. I'm going to use that equation. 3 times 5 plus y equals 15. That's 15 plus y equals 15. And y looks like it should be 0. That's my answer. Okay, let me do the happy check now. All right. 3 times 5 is 15 plus 0. It does equal 15. Happy check. Yay. Okay, next one. Number 14. Okay, let's see. Nothing I can cross out right now. So I am just going to try to get rid of x. Maybe multiply this by negative 3 and multiply this by positive 2. So this way, I'll end up with negative 6x there and positive 6x there, which are opposites, okay? So rewrite this. I end up with negative 6x minus 9y equals negative 21, okay? And then if I rewrite this, I get positive 6x plus 8y equals 20. Let me just double check and make sure I distribute it correctly. That does give me negative 6x, negative 9y, negative 21. Check, check, check. And that's 6, 8, and 20. Okay, perfect. All right. So I'm ready to combine them. So this one cancels out. So I end up with, what is it, negative y equals negative 1. Multiply both sides by negative 1. I get y equals positive 1. Okay. Now I'm going to take that equation and then go 2x plus 3 times 1 equals 7. Subtract 3 on both sides. So I get 2x equals 4. Divided by 2 on both sides, x equals 2. So my solution is 2 and 1. Let me do the happy check. So here we go. 2 times 2 is 4, plus 3 times 1 is 3, and 4 plus 3 is 7. Happy check. Ta-da! All right, number 15. Okay, so neither one can be gotten rid of the way it is. I'm going to multiply this whole thing by, I don't know, 2. And this whole thing by negative 5. Okay, goal is to get 10x and then negative 10x here. So here, this one turns into 10x minus 4y equals 6. And then this one turns into negative 10x plus 15y equals negative 50. Okay, and I can combine them now. So that cancels out. I get 11y equals negative, what is that, 44? Divided by 11 on both sides, so y equals negative 4. That's my answer for that. And then I'm going to try to find y, x from using that equation. Let me use the blue. That equation. So 2x minus 3 times y is -4 equals -10. That's 2x plus 12 equals -10. Subtract 12 on both sides. I have 2x equals -22. Divided by 2 on both sides, I get x equals -11. So my answers are -11 and -4. Okay, and of course it's time for the happy check. So x is -11, 5 times -11 minus 2 times -4. Ooh, that one does not look like it's gonna give me the correct answer. Did I make a mistake somewhere? I guess we shall find out. That's -55 plus 8 is so not 3. So where did I make mistaken? This is actually good because, yeah, I can go back and check. So let me check. Let me just double check and make sure I did distribute correctly. That's 10x, that's 4y, and that is 6. And that's -10x. That's, it is positive 15. And that is -10. Okay, so those things are all good, I feel like. And then when I added them together, divided by 11, that is -4. Did I make a mistake with this here? 2x, and then y is -4. 2x plus 12 equals -10 minus 12, -22. Huh. I feel like I did this correctly. What is going on here? Those of you who see my mistake are probably very frustrated right now. Oh, Miss Ying, I'm trying, you guys. Did I check this wrong? Let me just double check and do the happy check on the second one. So I can maybe try to figure out my mistake. -22. That becomes positive 12. That does equal 10. Ooh. No, that becomes -10, right? -22 plus 12. So I need. Okay, I'm gonna redo this. Oh yeah. Sometimes if you can't figure out mistake, you can just redo the whole thing, and hopefully we can figure it out. Okay, so do the happy check, and if you can't figure out your mistake, redo it. Okay, redoing it. Or maybe this is no solution. Let me just redo it one more time. Okay, so multiply everything by -2. And multiply everything by positive 5. Okay, so here, -10x plus 4y equals -6. Right? And then for this one, I get positive 10x minus 15y equals positive 50. So I get -11y equals positive 44. Divided by -11, divided by -11, so y equals -4. Huh. Same answer. This time I'm gonna plug it into maybe the first equation and see. So 5 times x minus 2 times -4 equals 3. That's 5x plus 8 equals, not -3, positive 3. Subtract 8 on both sides. So I get 5x equals -5. Divided by 5 on both sides, x comes out to -1. So I do get different answer, huh? -1 and -4. But I'm going to plug it into the second equation for my happy check. So 2 times -1 minus 3 times -4. That's what? -2. And that's plus 12. So I do get happy check. Huh. Okay, so I got the correct answer, except for I don't know what mistake was there in the beginning, but here's my correct answer. Yay, it works. Hippie hooray. Okay. Right, next one. Solve using any method. Maybe I'll use I'll use substitution for this one. Okay, I'm gonna use substitution. That's just my personal choice. If you don't like it, you can use elimination or graphing if you want to. Y equals negative 7x plus 10. So I'm gonna take negative 7x plus 10 and put it in the place of y right there. Okay, that's 5x plus 2 times negative 7x plus 10 equals 11. 5x minus 14x plus 20 equals 11. That's negative what? 9x plus 20 equals 11. Subtract 20 on both sides. I get negative 9x equals, what is it, negative 9 divided by 9 on both sides. So x comes out to positive 1. I'm going to take this now and use this equation. Y equals negative 7x is 1 plus 10. Y equals negative 7 plus 10. Y equals positive 3. So x is 1, y is 3. Let me do the happy check in the second equation. Okay, so x is 1. That's, if I do 1 there, it's going to be 5 plus y is 3. That's 6. Does equal 11. Happy check. Okay, next one. I'll use elimination for this one. Multiply this by negative 2. So I end up with positive 4x minus 6y equals negative 8. Hey, wait a minute. Nope, it's not. I thought it was going to be, oh wait, is it the same equation? It is, huh? Because if I multiply everything by negative 1, that's going to be positive 4x positive. Ah, these are exactly the same equations. I don't even have to solve this. At this point, you can say infinitely many solutions. Okay, so if I do that, okay. All right, next one. So 2 more word problems. I think that's it, yeah. Okay. A collection of nickels and quarters is worth 4.25. The number of quarters is 5 more than number of nickels. How many of each coin are there? So for this one, I am going to, it's asking for number of nickels, number of quarters. So N is of course going to be number of nickels. And then Q is going to be number of quarters. Okay. So equation number 1, let's see. Let me go to this one first. Number of quarters is 5 more than number of nickels. So we translate that. Quarters is 5 more than nickels. There you go. Okay. And secondly, now it comes to money value. It's worth 4.25 total. Okay. Total value is 4.25. How much is a quarter? Quarter is 25 cents. So if you have 1 quarter, that's going to be 0.25. If you got 2 quarters, that's 50 cents. If you got 3 quarters, that's 75 cents, and so on and so forth. So whatever number of quarters it is, I got to multiply it by 25 cents to figure out the total money value, monetary value of this. Okay, so that's what I do because I'm looking for the total value of 4.25. Plus nickels, okay, same idea. It's going to be 0.05. Nickel is 5 cents times N. Okay. So for this one, I'm going to use substitution. Take that and place it in the place of Q right there. Okay. That's going to be 0.25 times 5 plus N plus 0.05 N equals 4.25. Distributed, I get 1.25 plus 0.25 N plus 0.05 N equals 4.25. That's a lot of decimals, but that's okay. It's all money. Okay, so if I combine these two, that's 25 cents plus 5 cents, that's 30 cents. And then, so I'm gonna, yeah, I'll just take one extra step. 1.25, bring it down, plus 0.30n equals 4.25. Subtract both sides by 1.25. So I end up with 0.30n equals 3.00. Okay, divide both sides by 0.30, which is 0.3 essentially. You cancel that out. So n, so we're looking at 3 divided by 0.3, you guys, okay, which is same thing as 30 divided by 3, which equals 10. So n equals 10. That's 10 nickels. We go here, figure out the quarters. Quarters is going to be 5, no, quarters was, quarters was 5 more than the nickels. That's 15 quarters. Except for it does not sound right, does it? 15 quarters, how much is 15 quarters? Let me just quickly double check. 15 times 0.25. Oh, 375. I thought it was going to be more than 375. And then 10 nickels will be 50 cents, so plus 50 cents. It is, wait a minute, Miss Ying. Okay, I did $50, not 50 cents. 3.75 plus 0.50 cents. It does come out to $4.25. Okay, so 10 nickels and 3 quarters. Let me write my final answer somewhere. So 10 nickels and 15 quarters. Final answer. Okay, all right, last problem. Tickets for the school play cost $5 for adults and $3.50 for students. If 250 tickets were sold for a total of $11.60 on opening night, how many adult and student tickets were sold? So our two unknowns are number of student tickets and number of adult tickets. So A, I'm going to do number of adult tickets. And for students, I'm going to do T. I don't like doing S, so number of student tickets. Easy equation. When they talk about total number, those are always easy. 250 tickets were sold together. Okay, so that's easy equation number 1. Adult tickets plus student tickets together were 250 tickets. Okay, so there's 1 for the amount, total number of tickets. And then we go to the monetary value. Okay, 1,160 total. Okay, so second equation has to do with money. It's $5 for adult tickets. So 1 ticket will be $5. 1 ticket will be $5. 2 tickets will be $10. 3 tickets will be $15. So essentially you're just multiplying by 5, multiples of 5. So 5A, okay? You just multiply number of adult tickets by 5. Plus, similarly, you'll do the $3.50 per student. So whatever number of students ticket is, you multiply that by 3.5. Okay, so if you have 2 tickets, it'll be $7. If you have 10 student tickets, it'll be $35, and so on and so forth. Okay, and the value equals 1160. Okay, so maybe, I don't know what. I guess I can use elimination method. Okay, you can use whatever you want. Okay, I'm gonna use elimination. Maybe multiply everything by -5 here, -5. So this one turns into -5a minus 5t equals negative, what's 250? 25 times 5 is, what is it? 125. Okay, 125.0. Okay, so let me just quickly double check my math because I don't want to make a mistake with it. 250 times 5 is, 1250. Okay, so we add up the 2 equations now. Okay, add up these 2 equations here, this one and this one. Okay, so there we go. That can be eliminated. And then I end up with what? Negative 1.5t equals, okay, Okay, it's going to be negative answer 1250 minus 1160. 0, 9, oops, 9, and then 11, so 90. Divide both sides by negative 1.5. T equals positive, so 90 divided by 1.5. Move one decimal place over, and x is 0. 15 goes into 15, 30, and then 60 and 90. So I think it's, what is it, 6 times. 15 times 6 real quick there, it is 90, okay? So 6 times, it gives me 90 even. So it looks like it's 60 tickets, okay? So it's 60 student tickets, because T was for student, right? So adult ticket is going to be, so I go back to this equation and then bring down that equation right there. Let me use actually blue, that equation right there. So A plus T, which is 60, equals 250. Subtract 60 on both sides. So A equals 190. So it looks like 190 adult tickets. And then 60 student tickets. Okay. Just for the sake of time, because the bell is going to ring soon, and I don't want the bell to ring on you, I'm going to check the answers using my calculator. So 190 adult tickets, and it's $5 each. 190, oopsie daisy. Miss Ian keeps pressing the wrong button. How do I go back? I'll just start over. 190 times $5 each ticket comes out to $950, okay? Plus $3.50 per student ticket, and there is 60 of them. So total comes out to $11.60, and that was the amount that was total, okay? So that's it. That brings us to the end of the review packet.